Hello, hello, sixth graders. One more video lesson for you before I return on Friday tomorrow. Woo! We are doing lesson 5-9, ratio reasoning and converting metric units. So the metric units seem a little intimidating at first because we're not used to them. Most places in the world use metric units, so you've heard some before, seen some before, I'm sure. We usually use those customary from our past unit. So let's take a look at our metric system and see how easy it actually is. Let's open to page 322 if you're not there yet. Our essential question is, how can you use ratios to convert metric units of measure? Let's look at example 1. And again, just remembered, make sure you copy down these charts. If you don't have them, you're going to want them in your notebook. All three of our charts are the same, which is nice. So with our length, our capacity or volume, and then mass or weight are all the same charts. The only thing that's different is our base word. So here we have meters as our base, here we have liters as our base, and here we have grams as our base. Otherwise, all of our other units are the same. If you think of language arts, how you learn about prefixes, we're adding those prefixes to our base. So we have milli, centi, deci, deca, hecto, and kilo or kilo. And that's going to be the same in the same order on all of these. I'll have to check when I get back tomorrow, see if Dalton and Trey came up with that rap for us. They're supposed to be coming up with one to help us remember our chart. So hopefully they've been working on that. All right, now we can look at example 1. Amelia is helping her father build a skate ramp. They cut a board 1 2/10 meters long to use as the length of the board as shown in, is the length of the board in centimeters correct? So if we look, it's showing us that it's 120 centimeters. We're seeing if 1 2/10 of a meter is going to be long enough. So I need to look at my conversion rate from meters to centimeters. The thing I love about our metric system here, look at this. They're all 1, 10, 100, or 1,000, which is going to make this so easy for us when we're converting. So I found meters to centimeters. I see 100 centimeters is the same as 1 meter. That's our conversion rate that we're setting up, 100 centimeters to 1 meter. I know I need it to be 120. I know that it is 1 2/10 meters, so I'm setting up my 1 2/10 meters to check to see if it equals 120 centimeters. Once we do the work here again, you can multiply across. So we have 1 times 1 2/10 is 1 2/10. So I also am multiplying the top by 1 2/10, and when we multiply, we see that it does equal 120. Now we need a quick review that super cool trick we learned a while back about multiplying or dividing by tens, 100s, 1000s. It's going to make it so much easier when we're doing this metric system. So if I take my number here, my 1 2/10, remember, if you are multiplying by 10, all you need to do is move your decimal 1 time to the right. All right, I'm going to get a piece of paper here and show you. You might want to add these in your notes too. All right, so if I was going to take 1 2/10 times 10, I would just be moving my decimal 1 time to the right. So whoop, we did some sound effects in my other classes. Can't remember if we did that last time we learned it, but just makes it a little more fun. So now I know that 1 2/10 times 10 is the same as 12. If I take my 1 2/10 times 100, I'm taking that 1 2/10, and this time I'm moving my decimal to the right 2 times. You can remember how many times to move it because you look at how many zeros there are. So in 10, there's only 1 0, so we move it 1 time. In 100, there's 2 zeros, so I need to move it 2 times. So now I can whoop my decimal, whoop, whoop, 2 times. And now it's here. Remember, if we have an empty space, we annex that 0. So now I know 1 2/10 times 100 is 120. That's how we got our answer here, 120 centimeters. So we knew our board was the correct length. All right, if I do my 1 and 2/10 times 1,000, we have 1, 2, 3 zeros. So I'm going to take my decimal point and move it to the right 3 times. Whoop, whoop, whoop. All right, annex those zeros. Now I know I have 1,200. All right, you can do that with any number that's a multiple. That's an exponent of 10. So times 10 times 100 times 1,000 times 10,000 times 100,000 times a million. You can use it for any of those if you're have a base of 10. Super cool is you can do the same thing with division. So if I had that same number, 1 and 2/10, and I was dividing by 10, the only difference is the direction you're moving the decimal. When you're multiplying, your number's getting bigger, so you want to move your decimal to the right. When you're dividing, your number's getting smaller, so you're moving your decimal to the left. All right, oop, there's a weird gloss on here, so those arrows didn't quite work. All right, so since I'm dividing by 10, there's 1 0, I'm moving it 1 time to the left. Whoop. Now I have 12 hundredths would be my answer if I was dividing by 10. All right, and again, if I'm doing it divided by 100, there are 1, 2 zeros, so I'm moving it to the left 2 times. Whoop, whoop. Annexing that 0. Now I have 12 thousandths. And one more time just for fun with some extra whoops. Here we go. If I'm dividing by 1,000, that's 3 zeros, so I get to whoop it up 3 times. Whoop, whoop, whoop. Here's my decimal. Annex those zeros. Now I know it's 12 10,000ths. This is going to be so helpful doing this metric system. This is why the metric system's awesome. Makes it so much faster. All right, let's look at our try it now that we looked at that trick. The middle of the skate ramp is 2 5/10 of a meter wide. Amelia and her father want to use a board that is 23 5/10 decimeters long. Is this board wide enough for them to use? Convert decimeters to meters. So if I look up here, I need to find decimeters and meters. I see that 10 decimeters, make sure you're at decimeters, not decameters, decimeters is 1 meter. So 10 decimeters is 1 meter. I want to convert decimeters to meters to check to see if it's long enough. So I have 23 5/10 of a decimeter. All right, here's where that trick's going to come in handy. We can do our crisscross. Since all of our conversions have a 1, we're either multiplying or dividing, and then multiplying or dividing by 10, 100, or 1,000. So if I take my 1 times 23 5/10, it's 23 5/10, and then I am dividing by 10. Remember, if I'm dividing by 10, I'm just moving my decimal point. I'm whooping it 1 time to the left. Whoop. Now that I divided, I know it's 2 35 hundredths of a meter. So if we look, we can see if it is long enough or not. So how long did it need to be? It needed to be 2 5/10 meters long. It is only 2 35 hundredths meters long, so it is not long enough. All right, the beginning of the lesson was pretty long, so of course we are going to check out some more of those memes you made. All right, let's move to example 2, converting metric units of capacity. So now with capacity or volume, our measurement is in liters. So Raj poured 150 liters of water into an aquarium. How much more water does Raji need to fill the aquarium? If we look, we see that the capacity is 2 2/10 hectoliters. So I need to find my conversion for hectoliters and liters. So here we go, hectoliters and liters. 1 hectoliter equals 100 liters. Then we're going to set it up to what we know. We know our capacity is 2 2/10 hectoliters. When we write it across from each other, since they're across, you can just do your times 2 2/10 or times 2 2/10. You could have also done the crisscross. Either way works. When we take our 2 2/10 and we multiply by 100, we're moving it twice. Whoop, whoop. There we go. Now I know it's 220 liters. Pretty quick and easy. All right, we're just going to move straight to example 3 since that was fast, and then I'll throw in some more of those math memes at the end for you. Converting metric units of mass. So again, same measurements, just a different base. This time our base is grams. Lyle has a bowl that contains 8/10 of a kilogram of salt. He uses a spoon to remove 850 centigrams of salt. How much salt in centigrams remains? So the first thing we're doing is calculating our conversion rate of kilograms to centigrams. If I look over here, I don't have one from kilograms to centigrams. So this is going to be a 2-step process. We are going to have to take our kilograms and convert them to grams, and then take those grams and convert them to centigrams. So let's start with kilograms and grams. We have 1 kilogram is equal to 1,000 grams. We have 8/10 of a kilogram. So if I use that crisscross or multiplying across, I'm going to end up with my 8/10 times 1,000. I'm going to do that down here. If I'm timesing it by 1,000, I'm whooping that decimal 3 times to the right. Whoop, whoop, whoop. There we go. Now I know that it's 800 grams. Now that I have my measurement in grams, I'm going to take my conversion rate of grams to centigrams. So I have 1 gram is 100 centigrams. I'm going to set up that 800 grams that I just found. I know that I'm going to be multiplying my 800. Remember, if it's a whole number and there's no decimal, it's the same as if that decimal's at the end there. I'm taking my 800 times 100, so I'm whooping it twice. Whoop, whoop. Annexing those zeros. Now I know that it's 80,000 centigrams. See how quick and easy that was? Even with it being 2 steps, it was still pretty fast with that metric system being all bases of 10. Let's do one more try it before you head to work time today. To make violet paint. Oh, we didn't finish the question. Got to go back. The question was, how much salt in centigrams remains? So once we found our 80,000 centigrams, we're subtracting the 850 centigrams he scooped out to find that there's 79,150 centigrams left. All right, that was a close one. I almost forgot to finish. Next one's going to be the same thing, where we're going to have to answer a question after we do our conversion. So make sure you're always reading carefully to see if there's more than just the conversion itself. So here we have, to make violet paint, Iris mixes 25 hundredths of a liter of red paint, 25 hundredths of a liter of blue paint, and 4 5/10 of a centiliters of white paint. How many centiliters of paint are in the mixture? So we have 3 different measurements, and we want to combine them and have them as centiliters. So 4 5/10 centiliters is already centiliters. That's nice. Here we have 25 hundredths of a liter and another 25 hundredths of a liter. If I add those together, I know it's going to be 5/10 of a liter, or 50 hundredths, but we can change it to 5/10. That will help us with our conversion. So we want liters to centiliters. If I look up here for my conversion rate, all right, remember this is grams, but it's still the same thing. 100 centigrams is 1 gram, so 100 centiliters is 1 liter. And if you want to double check just to see it, 100 centiliters is 1 liter. I can set it up equal to my 5/10 of a liter. So liter to liter, again, labeling to make sure you have them matched up correctly. If I do my crisscross, I'm going to be multiplying by 100. Kind of running out of room here. Should have got some more paper. All right, multiplying by 100. I'm whooping it twice to the right. Whoop, whoop. Now I have 50 centiliters. I'm not done though. Not only do I have 50 centiliters, but I also had that other 4 5/10 centiliters. So I have to add those together. If I'm adding my 50, I'm going to annex that 0 so I can line up my decimals. And then I end up with 54 5/10 centiliters of paint. So now I know the whole mixture had 54 5/10 centiliters of paint. All right, you have your IXL to work on today. The assignment will be on the next page for you. And then I'll throw up a couple of those I will put some of those last memes on the screen for you to check out what your classmates came up with. See you tomorrow.